Hello, calculus fans. So we're going to define the derivative of a vector function, and it's defined basically the same way as it is for real valued functions. We're going to say that dr by dt, or we can write r prime, is just the limit as h goes to 0 of r of t plus h minus r of t all over h, provided this limit exists. Let's show what the geometric significance of this derivative is in the next picture. So I've got two pictures here. The first picture shows you a secant vector. That's the vector that goes from P to Q. That's a secant vector. That secant vector turns into a tangent vector when you take a limit as h goes to 0. The red vector that you see here is the tangent vector. So the points P and Q have position vectors r of t and r of t plus h. Then PQ is r of t plus h minus r of t. We're going to think of that as a secant vector. And then, as long as h is bigger than 0, then 1 over h times that points in the same direction as r of t plus h minus r of t. And as h goes to 0, what it looks like is that that vector approaches a vector that lies on the tangent line. So we're going to call r prime of t the tangent vector to the curve defined by r at the point P. Now this provided that r prime of t exists and that r prime of t is not equal to the 0 vector, which it might be. The tangent line to C at the point P is defined to be the line through P parallel to the tangent vector r prime of t. Later on we're going to talk about the unit tangent vector. That's defined to be r prime of t scaled down to a unit vector. In order to compute a derivative, all you have to do is just differentiate each component. It's pretty straightforward. So the derivative of r prime of t is the vector where the components are differentiated. So it's f prime of t, g prime of t, h prime of t. Okay, that's all for now.